The phantom signals in the cosmic web, fast radio bursts, plasma optics, and the illusion of messages with no sender. Prologue: the flash that makes empty place look crowded. It begins at a vertical scratch in the universe, an event so brief that it should be impossible to study, and yet so bright that it forks itself into our achievements. A fast radio burst lasts milliseconds. In that instant, it can outshine entire galaxies in radio power, then it's gone. For years, these bursts felt like cosmic jump scares, unlocalized, unrepeatable, and untrustworthy. But then they multiplied, and then some of them repeated. And once they repeated, the story changed from a strangle signal to a population of astrophysical events. But the new problem emerged, one that is even harder to explain than the bursts themselves. Some FRBs don't just achieve, they arrive at if the universe edited them, split into sub-bursts, chopped into bands, encoded into multiple copies, penned into patterns that look engineered. That's the phantom problem. When a signal looks like a message, how do you prove whether the sound is speaking or the part is rewriting the speech? Tonight is not about aliens. Tonight is about something more unsettling for our intuition. Empty space is not empty, and it can impersonate intention. Chapter 1: What an FRB is. The one sentence that matters. An FRB is a millisecond radio pulse that arrives later at lower frequencies because it traveled through plasma. That delay is dispersion. It's not a detail. It's the first hard clue that FRBs are not local artifacts. They carry a measurable record of how many free electrons the radio wave encountered on its way to Earth, and that makes FRBs special in a way few astronomical sounds are. They are not just events, they are probes. Every burst is an experiment performed by nature, a clean input pulse sent through an unknown medium, then recorded at an output waveform with distortions that can be modeled. If you understand the distortion, you learn about the medium. That you misunderstand it, you hallucinate the story about the source. The entire episode is about avoiding that mistake. Chapter 2: The Cosmic Web as an Optical System. Most people imagine the cosmic web as a map of galaxies, but for radio waves, the web is something else, a refractive medium. Between galaxies lies ionized gases, thin, hot, often invisible in image. This plasma can disperse the signal, frequency-independent delay, scatter it, temporal broadening and toast, scintillate it, frequency time, twinkling, rotate its polarization, throws magnetic plasma, and under the right density gradients, lens it. So, the cosmic web is not merely background, it's a set of lenses and screens distributed across the universe. That is a foundational twist. When you look at a FRB, you are not seeing the poor source. You are seeing a short, filtered through intergalactic optic. Chapter 3: Why words do not mean intentional. Human brains are pattern detectors. The time frequency pulsed, we see structure and imaging meaning. But plasma is an art of convincing patterns. A turbulent medium can create multiple apparent components from one emission, drift-link sharp burst, sharp bending, equal light duplication, and complex interference-like structure. These patterns can look good because they are structured, but their structure may come from physics, not intention. So, we set a rule for the episode. Before any extraordinary interpretation, every pattern must defect a long list of ordinary physical editors. The universe must be cross-examined. Chapter 4 Suspect Zero The Instrument and the People Life. FOB science is built for people life. That's not criticism, it's reality. A modern radio telescope produced a torrent of data. Bursts are found by the dispersion algorithm, thresholding and candidate ranking, RFI excision, and automated classification. It means the people life can create phantoms if radio interference imitates dispersion swap. A dispersion bug creates false alignments. A classifier learns wrong patterns, or aggressive filtering erases real phenomena. So, the first section of the case file is not astrophysical. It's a procedural. Multi-site confirmation when possible, injection and recovery test, and strict metadata audit, time, frequency, antenna state, non-RFI remains. If the signal cannot survive that, it cannot enter the story. Chapter 5 Q Test 1 The Dispersion Law. Cold plasma dispersion had a characteristic frequency dependence that is the universe signature, and it is hard for terrestrial interference to mimic perfectly. So, the simplest Q test is, does the arrival time swap behave like plasma physics? If it fails, the signal is suspect. If it passed, the signal is allowed to be cosmic, but is still not allowed to be mysterious death. Passing a dispersion law only proves the signal traveled through ionized medium. It does not reveal when the medium is, how it is structured, or what the source is. It simply tells you a part of the phenomenon. Chapter 6 The Phantoms Reframed. One burst, many parts. There is a concept that changed everything. A single burst can arise along multiple paths. If plasma irregularities created multiple refracted rows, you can receive a same burst with tiny time-obsessed, different spectral weightings, and different appearance substructure. It creates an illusion of repetition without repetition. The signal did not happen twice. Space delivered it twice. That's why echoes and multiple components cannot be interpreted as multiple emitters until propagation has been modeled aggressively. The phantom problem is often a geometry problem. Chapter 7 Scattering. When the medium plus time. Scattering is not dispersion. Dispersion delays. Scattering smears. The scattered burst often had a tail. Pulse energy scattered into later times, stronger at lower frequencies. That behavior can be modeled and tested, and is equaled turbulence, scale, and strength in the plasma. Scattering matters because it can make bursts appear longer than they are, create asymmetry that looks like intrinsic emission structure, and biased detectability by spreading peak intensity. A burst that looks complex may be simple emission seen through a scattering stream. So, scatterings must be fitted, not assumed. Chapter 8. Scintillation, the universe's triangular filter. Scintillation is a radio version of starlight shrinking, interference, and focusing from plasma irregularities. It can amplify or suppress signal in frequency paths, creating band structures that look intentional. It also creates selection bias. Surveys detect more pushed when scintillations have them. That means the observed population is not just the intrinsic population, it is the intrinsic population multiplied by the medium's focusing lottery. It matters from the great silence of counterparts too. A burst may be intrinsically modest and only visible because it was temporarily paused. So, before inferring engineer skill, you must account for the possibility that the medium turned a whisper into a sound. Chapter 9. Plasma lensing, optics that change with frequency. Now we reach the cinematic editor, the plasma lens. A plasma lens is not like a glass lens, it's a dispersive. Its focusing depends strongly on frequency. That means it can create narrowband amplification, time frequency caustics, apparent subburst split, and drip patterns that resemble desired structure. Crucially, plasma lensing is testable. It predicts how amplification should serve with observing band, how patterns evolve as a line of sight changes, and how repeated bursts can enter and leaving a focusing in means over days to weeks. If the burst weakness follows this prediction, the weakness belongs to the part, not the source. It is where the cosmic web becomes an optical laboratory. Chapter 10. Q Test 2. Chromatic with achromatic behavior. Here is one of the cleanest discriminators. Plasma effects are chromatic, frequency dependent. Gravitational lensing is achromatic. In vacuum, bending is not frequency selective. So, if you suspect lensing, either plasma or gravity, you test the frequency behavior. A gravitationally lensed FRB should produce multiple images, repeated bursts with identical dispersion measure, consistent spectra, modular noise, a stable time delay, and no strong frequency-dependent focusing signature. A plasma lens burst should show frequency-independent magnification, drifting caustic, and spectral structure that change with band in characteristic way. This Q-test is not about preference, it's about refusing to confuse two different kinds of optics. Chapter 11. The gravity lens possibility. FRBs are stopwatches. If an FRB is gravitationally lensed, the time delay between images can be milliseconds to days. It's extraordinary because FRBs are intrinsically brief. They left Earth menstrual delays with a ridiculous precision. If confirmed, lensed FRBs would become probe of contact lens populations, constraints on small-scale structure, and potentially tools for a cosmological inference via time delay geometry. But the standard of proof must be strict, multiple bursts with the same TM and stable delay, replicable across bands and instruments. Because plasma can emit some echoes, the case must be altered. Chapter 12. Polarization. The magnetic signature of the path. F-orbits are often polarized. Some exhibit extreme relation measure, RM, indicating polarization through strong magnetic fields and dense plasma. RM adds a new acid. It can localize when the strongest magnetized plasma is near the source in the host environment or is in an interverting structure. It can evolve with time in repeats, and it can correlate with changes in pulse morphology if the local environment is changing. Polarization is a fingerprint that the instrument cannot easily forget and the sound cannot hide from if the part is magnetized. So the expression logic as a principle. If morphology changes accompany RM or scattering changes, the medium is likely editing the message. Chapter 13. The home problem. Hosts do not solve the phantoms. Localization helped. It gave F-orbits address, but address created a new misunderstanding. The host is not the world environment. An F-orbit can be shaped by its immediately local plasma, nebular, winds, remnants. Its host galaxies interstellar medium, intervening halos and groups, the intergalactic medium in filaments, and the Milky Way itself. So, a host identification does not eliminate propagation effects. It often makes them more important because now you can separate distant terms and modal contributions. The home tells you where to start the accounting. It doesn't finish the accounting. Chapter 14. The electron ladder. GM is a sum of many placed. To view F-orbits at a cosmic web proper, you must split the dispersion measure into components. Milky Way contribution, Milky Way halo contribution, intergalactic medium contribution, intervening structures, host galaxy contribution, and near-source local environment. As this composition is the Laker problem. It's also when many overclams are born. If you attribute too much GM to the IgM, you overestimate web variance. If you attribute too much to the host, you underestimate web variance. So, the fields must treat GM as a probabilistic bucket with uncertainties, not a single clean subtraction. A dissimplified story is, given the host and this redshift, the IgM contribution is constrained within a range, and a range is what becomes science. Chapter 15. Cross-correlation, making the web confess statistically. Single F-orbits are messy. The web is statistical. The correct move is correlation. If higher GM side lies align statistically with higher foreground galaxy density, non-filament spins with group environments, then the web is implicated in a way that individual event narrative cannot affect. This is a key methodological update. You stop trying to read the web from one burst. You let thousands of bursts average away host chaos and reveal the scale structure. As how phantom editing becomes useful. Once understood, it's become a tracer of otherwise invisible variance. Chapter 16. The message illusion. Weak aliens comes for first. You can say this cleanly without ridicule. If something looks like a message, physics still gets first right to refusal. Because plasma can create structure, and selection effects can amplify structure, and people eyes can emphasize structure. Nature is fully capable of producing patterns that trick our intent distinct. To seriously claim a beacon, you should need repeatability with stable encoding cross-bands, behavior inconsistent with the propagation optics, a multi-instrument confirmation that drew out people-like shaping. No such evidence exists in the credible literature as of my knowledge cutoff, August 2025. The strongest and most consistent explanations remain astrophysical engineers plus propagation. So, the responsible documentary since it the illusions of masses is a feature of conflict media, not evidence in intent. Chapter 17. The injured you, treated like science. Injured mother, but injuries is not allowed to explain everything. A rigorous approach ties engineer to measurable output, repetition, statistics, engineer distribution, polarization behavior, host demographics, association with persistent radio source, or star-forming reasons, and any multi-wavelength counterpart constraints. Minor stars are the strong challenge for many repeaters and perhaps some one-offs, supported by at least one galactic event, but the field may include multiple channels, and environment difference can make one engineer look like many. So we treat the engineer's rule as a population inference problem, not a list of imaginative possibilities. Chapter 18. The cleanest near-term smoking gun. For the episode theme, the most decisive smoking gun is not near, but the part. A clean plasma lens event with a predicted chromatic caustic evolution would prove that the medium can produce phantom structure without multiple emissions. A clean gravitationally lensed FRB with identical DM can stable achromatic delay would prove that compact mass structures can duplicate a pulse like a cosmic echo chamber. Either will turn today's interpretive debate into a measurable model given remains. The reason to watch such a smoking gun is not drama, it's in calibration. Once you know how much edited space can do, you stop misattributing editing to engineer. Chapter 19. Next Gen Listening. Why volume is destiny. The next decade is about scale. Thousands to tens of thousands is located. FRBs change the field in three ways. 1. Rare lensing events become inevitable if they exist. 2. TM redshift relations become precise enough to map missing variants. 3. Subclasses emerge gleaning from statistics rather than from the unasked. Volumes is not hyper. Volumes is a trap for the universe. If a phenomenon occurs at a non-zero rate, enough sky time forces it into a catalog. That how invisible structures stop being an argument and become a measurement. Chapter 20. The philosophical landing. Space is not a void, it is a medium. The deepest point of the episode is simple. Astronomy is not only about stars, it's about the space between stars. FRBs did this brutally well because they are so fast and so clean that the medium's influence is impossible to ignore. The cosmic web is not a silent background, it's an editor. It delays, smears, focused, polarized, and something splits. So, the phantom signals is not embarrassment. They are information. Once you learn the grammar, the universe is not sending messages. The universe is revealing its medium. Epilogue, a web you can hear. A century ago, a cosmic web as an inference, then lensing and surveys mapped its skeleton. Now, FRB is often something new, a way to sample its plasma content along countless nestled through blazed. At catalyst growth, the web will become not only something we see at the mass contours, it will become something we measure at the dispersion, variance, scattering strength, and magnetization, a weather map of intergalactic space. In that sense, the cosmic web is already speaking, not in language, in propagation. And the more we listen, the less the quantums look like mysteries, and the more they look like the universe finally revealing what empty space actually contains. Chapter 21. The first real turning point, when the burst gets an upgrade. A moment that FRB is located precisely is the moment the story stops being a campfire mystery and becomes an accounting problem. An address gives you redshift. Redshift gives you distance. Distance gives you a right to ask how much of the dispersion comes from the intergalactic medium and how much is local. Without localization, every dm value is a guessing constant. With localization, dm becomes a lagger. But the localization also introduced a new danger. Once you know the host, you can become emotionally attached to the narrative about the engineer. You might interpret every stage train structure as a sound physics, when in reality the parts could be editing the signal. So the turning point is not we found the host. The turning point is we can now separate what belongs to the source from what belongs to the highway. Chapter 22. The Laker method. DM as a distribution, not a subtraction. A common mistake is to treat dispersion measure like a dimple diffraction problem. Milky Way model means observed DM equals intergalactic DM. That's not the discipline that the wistful arithmetic. The correct approach is termed as the distribution with uncertainty. Galactic DM has molar error and spectral variation. The Milky Way halo has uncertainty in extent and electron content. The host galaxy contribution depends on inclination, star formation, and local environment. The near-south contribution can dominate the summed register. The EGM term varies with either the site-like crosses, filament, groups, or voice. So, TM is a probabilistic budget. When you treat it that way, you stop climbing. We measured the EGM exactly, and you start climbing something more honest and more powerful. We constrain the EGM within a range and arrange script systematically with environment, that it grand mapping become possible. Chapter 23. The phantom patterns are the classiphysical problems. Once you accept that the past can edit signal, the next question becomes, how do you classify the edit? Instead of treating every burst like a unique snowflake, you categorize distortions into families. Dispersion dominate burst, clean swept, minimal scattering. Scattering dominate burst, tail broadened profiles. Scintillation dominates burst, patchy spectral energy. plasma lens candidate, costing light bending, extreme chromatic amplification. Potential gravitational lens candidate, repeated event with stable delay and matte DM. It's not a cosmetic autonomy. It's how you stop telling stories one person at a time. Populations are the antidote to hallucination. A classification framework lets you ask, do certain morphologies correlate with host time, restrict, for growth, structure density, or rotation measure? If yes, you are reading the medium. Chapter 24. The host environment trap. Why local can dominate everything. The most dangerous co-founder in FRB cosmology is local environment. A young magnet star inside a dense nebula can contribute enormous DM and RM, and that's contribution that evolved. That means two birds from the same image can look like two different physical processes if the environment is changing. So, when people attempt to use FRBs to map missing parents, the first discipline is to trick repeaters and highly magnetized environments differently from cleanser stylized. The practical implication is uncomfortable but necessary. Not every FRB is equally useful for cosmography. Some FRB are better engineered laboratories, some are better web-proofed. A major field does not fork all events into one use case. Its field selection criteria. Chapter 25. Q Test 3. Multi-band consistency. If a phenomenon is real and physical, it should have consistency under different observing bands in ways the models predict. Plasma lensing signatures should evolve with frequency strongly and predictably. Gravitational lensing signatures should remain achromatic in delayed and mark DM precisely. Instrumental artifacts should often change character when receiver changes band pass or side chains. So, one of the strongest credibility updates is a multi-band observation. The same burst or repeating burst from same source observed at different frequencies isn't just more data. It's an attempt to force the editor to reveal itself. If the witness moves with frequency as plasma optic predicts, the path is responsible. If it remains stable, you must look elsewhere. Chapter 26. The scattering skin. Question. Where is the blur located? When the pulse is broadened, it's tempting to say, the IgM did it. But scattering can occur in many places near source environment, host galaxy ISM, intervening halo or grouped Milky Way ISM. Locating the scattering skin is a detective job. It uses frequency scaling of scattering time, correlations with RM and tubular duration, side-light comparisons across nearby sky regions, and, when possible, repeated monitoring to see whether scattering changes over time, suggesting local host origins. If you can locate the screen, you convert mysterious blur into measured turbulence in a specific environment. And that matters because turbulence is part of the cosmic web plasma physics story. Chapter 27. Magnetization. Why RM is a gold standard witness. Rotation measure doesn't merely tell you there is a magnetic field. It tells you where magnetized plasma might be concentrated. Let RM Veilers often point or to sense magnetized local environment, supernova remnants, nebulous galactic centers, moderate RM veilers that correlate statistically with foreground structure can hint at the magnetized halos or filaments, but RM must be used carefully if it is sensitive to geometry and field reversal. A small measured RM does not mean no magnetic field. It can mean cancellation along the line of sight. So, the proper use is population level. To FRB behind denser webbed environments show a systematic shift in RM distribution? If yes, that evidence of intergalactic magnetization patterns. If no, the upper limits tightened. Either way, RM is a level that few other probes can match. Chapter 38: The Cross-Correlation Campaign: Turning Purse into the Web Atlas. Here is how you build a web atlas from FRBs without cheating. 1. Take a lead sample of localized FRB with host registers. 2. Build probabilistic decomposition from 4 DM terms: galaxy, halo, host, local, IgM. 3. Cross-correlate residual DM with foreground galaxy density, field, and filament catalog. 4. Look for coherent signal, higher DM residuals along filament rich sidelights than void light sidelights. 5. Validate with new test, scrambled position, rotated filament maps, random catalogs. If the correlations survive new, you have something powerful. We are mapping variants in the web without directly imaging them. It is a phantom transformed into an instrument. Chapter 29: The Four Positives That Every Field Must Survive. Every time dormant fields eventually suffer as a dramatic four position. A pattern that looks like discovery until it's collapsed under better test. FRBs will have their own versions, claimed periodicities that vanish more data, lensing candidates that for a dramatic test, exotic chord structure that turn out to be scintillation plus selection bias. This isn't embarrassing, it's formative. It is the community with test matter. In the documentary, this chapter is central because it inoculates viewers against hyper. It also reinforced your channel terms. The universe is measurable, but only if you build the right adversarial standards. Chapter 30: The Ancient Part. Science statistics, stop trying to pick one. The major explanation is not genes on part, it's engine and part. The engine set the raw emission, the part edited it. The detector reconstructed it, the people classify it. The observed burst is the product of all four layers. The mystery is solved when you treat the world changed other phenomenon. Then the question changed from what is a true burst and how do we infer the stars properties given the editor. That's not less exciting, it's more powerful. It turns FRB into laboratories for post-compact object physics and intergalactic medium physics simultaneously. Chapter 31: The Rare Event Trap. Hunting lensed FRBs. If gravitationally lensed FRBs exist at a non-zero rate, least catalogs should eventually force them into view. The lensed FRB candidate had an unusually strict signature, repeated bursts with identical DM, stable time delay, consistent polarizations behavior within noise, no strong chromatic focusing signature. A confirmed event would instantly expand what FRB can do. Constant compact lens populations, probe small-scale structure, and potentially mensural cosmological parameters through lens geometry. But the key is description. Because plasma can mimic a karst, lens clamp must be held to the Christie standard in the episode. Chapter 32 Microlensing or FRBs, a new window on small masses. There's an even sharper possibility. Microlensing can create interference-like effect at radio frequencies and produce subtle distortions in time-frequency structure. It's complicated physics and must be treated conservatively, but the value is enormous. FRBs are short and bright enough that they could detect tiny gravitational perturbations that would be difficult to see in other regimes. If it becomes measurable, FRB become proper of compact mass populations and substructure in a way that plays directly to the dark clumps story of episode 5. So, episode 6 can quietly become a sequel to episode 5, not a repeating, but by using different messengers. Chapter 33 The Practical Checklist When a phantom is clamped already. To keep the documentary trustworthy, state a checklist. A phantom feature is clamped ready when it survives independent people-light and RFI audits, shows models consistent scaling with frequency and time, persists under multi-band observations, 4 new tests, crumpling, rotation controlled, and ideally correlates with independent environment trigger. Foreground structure density, host properties, RM trends. Without the checklist, the episodes become pattern worship.